Hello class, welcome sa ato ang new topic no. So we are progressively moving forward sa ato ang discussion. We are already now on our module 13. So let's talk about the equations of motion, the normal and tangential coordinates. Okay, so kan siya gyapon actually medyo related ani sa ato ang previous gyapon nga mga discussion sa Newton's second law, then partner with the normal tangential components no sa katong ni acceleration. Okay, so we know that the motions of the particle doesn't only move with straight line, but they also move in curve, no? So ga-move siya in circular or curved paths or parabolic. So actually atong objective for this module is to learn how to formulate the three equations of motions using normal and tangential coordinates. Okay, so ingon na ganito coordinates. So di ba natay mga x and y coordinates? Here we'll be using the normal and then the tangential coordinates. So okay. So shown here, we have a particle that moves along a curved path. So curved path man gyud natong gistoryahan, which is unknown. The equation of motion for the particle may be written into the tangential, normal, and binormal direction. So lakasir unsa naman ning normal, binormal, tangential nga directions. So di ba in translation of axis we have the x and we use the x and y component man. But in real life ang motion kay movement siya into curve or parabolic or circular path. So basta curve na gani, parabolic and circular path, ato nang ginagamit dira is dili na x and y, di ba? We have the normal nga direction. We have also the tangential component. So more yung normally ito lang ginistorya is normal tangential, but here nati added nga binormal direction. So unsa man yung binormal direction? So pinumdum lang ko balik no with the Newton's second law of motion. We note that the force is equal to the mass times the acceleration. And then the direction of the force, kung imo na siyang isum, is just equal to the mass times the vector acceleration. So this is, so kung inyo makita dire, we have the bold F and then the bold A. So again, the bold letter and the bold F here and the bold A represents a vector quantity. Sa ato pa, we consider na nga different path of motion. So instead of using the rectangular components for this one, the x, y, and z components, we use for the curve motion as the tangential, normal, and the binormal motion. So we have a force, summation of force along the tangential direction. So kaning ut again diri, this is just a unit vector. It describes the motion. So pwede ra gyud nato na siya isulat no as something like katong namurag arrow sa ibabaw. So force t plus the summation of force along n, the normal, plus the summation of force along the binormal in vector quantities. So these are in vector quantities. This is just equal to the summation also of the mass times the acceleration. So mass times the acceleration of tangential plus mass times the acceleration of along the normal. So, ganong walay mass times acceleration along the binormal. So ato na ipakita diri. So, di ba is sa ato ang circular motion or curvilinear motion, if we have a particle that moves, let's say, along that way, di ba natin, let's say, velocity here. So, this is the tangential acceleration of the said particle. And then, ang normal nga acceleration of the particle is towards the center of the motion. Now, atong gina-discuss na dire last time, we have the normal, the tangential. Here, we have the binormal. So, natin acceleration along the tangential and then acceleration along the normal component sa direction sa curve. So, kaning binormal, if we draw the particle, let's say this particle here moves along a curve. Yes. And then, let's say ang iyang curve is money ang tangential component. Let's say we call that a sub t. And then, the normal component here, we have here the normal acceleration. Let's say this is towards the center, O. So kana siya, this is the normal, then this is the tangential. Napo na siya binormal component. This is the binormal component. So we have the binormal axis here. We have the normal axis on this side and the tangential axis on this side. So, di na taga xy component but we use the normal, tangential, and the binormal. Since a particle ga-move along this way, kumutuyok na siya, so we have the tangential acceleration. We also have the normal acceleration. But on that side, kay dili man gaana ang motion, gaana ra siya. Let's say, maski pagpaana siya nga side, binormal is always normal to the normal normal nga acceleration and always normal to that tangential acceleration. So on this side, wala ni siya acceleration. That's why, actually we can write it here as mass times the acceleration along the binormal, but since there is no acceleration at binormal, that is just 0. So we can just sum the summation of forces, or the summation of force along the tangential plus summation of forces along n and summation of forces along the binormal axis is equal to the mass times the acceleration of the tangential and then the normal nga component. So mao gyud ni siya ang mahitabuan ni. So 0 man ang binormal. Actually, we can further simplify this as like this: summation of forces along the tangential with the unit vector u sub t. So kaning u sub t, wala siya value, mura lang ni siya nag-show kung asang direction. This is unit vector along the tangential plus summation of forces along the normal, u sub n, plus summation of forces along the binormal axis is equal to mass times the acceleration along the tangential plus acceleration along the normal. So kung ato na siyang tagsa-tagsaon, so mo ni siya ato ang makuha. Summation of forces along the tangential is just equal to mass times the acceleration nga tangential. Summation of forces along normal is just equal to mass times the normal acceleration. And the summation of forces along the binormal is equal to 0. On account nga ang acceleration along the binormal is just 0. So, same rin po diri ang principle before nga nag-apply sa curvilinear motions. A sub t is just equal to the derivative of the velocity with respect to time. And then a sub n, the normal acceleration, is just equal to the square of the velocity over the radius of curvature with respect to time. So, mao ra gyapon na siya diri, nadugangan na taog binormal direction or component sa ato ang particle.